Hello, so we're doing number 31, which is using derivative graphs to graph. And so we have an f double prime of x graph, an f prime of x graph, and an f of x graph that is yet to be filled out because we're going to use these two functions here to find our f of x graph. And so part of that, the first part we're going to look at is in creating the f of x graph is off of f double prime of x. We can tell concavity. And so from negative infinity, just from our graph -4, to 0, we're going to have concave down because it's negative. You don't have to draw it yet. And then, and then from 0 on is going to be concave up from 0 to 4. And then for f prime of x, that's going to tell us two really important things, where f of x is increasing or decreasing, and the slope at these different points, which is going to help us get an accurate measure of our graph. And so, for example, just to start, on -4 to, well, first we're going to look at our critical point, On f prime of x, we can see that the velocity graph, or just the derivative, is 0 at -1 and 1, which means that the particle stops and has either a relative max or a relative min. And so we can tell that because the graph initially is positive and it comes down to negative at -1, therefore there is a max for f of x at x equals -1. And so
it's going from increasing to decreasing.
So you can just draw a dot at -1 where there's going to be a max up there. And so then on x equals 1, the derivative graph goes from negative to positive, so there is a min. So you can draw a min down there. And then just one little thing that we can tell off of this might be kind of out of order, but we can tell that off of the velocity graph at x equals 0, the slope is -1. So in between the max and the min, we can tell that there's going to be about a -1 slope connecting the two. All right, so looking at the graph, if we know from -4 to 0, it's going to be negative second derivative. That means it's concave down. And from on f prime of x from -4 to 0, or -4 to -1, we have positive, which means f of x is increasing. So it's concave down from -4 up to that max, and it's increasing the entire time. So we got
Concave down.
a function that kind of looks like there, and it reaches its max. And then as you see, it starts to come back down at a slope of -1. And so you can just go ahead and continue to -1 to our min right over there. And then the second thing is going to, I guess we could need our slopes. But anyway, continuing on, the second derivative from 0 to 4 is positive, which means our graph is concave up. And then the f prime of x, as we go through here, it goes from negative to positive, so it's min.
Decreasing to increasing.
And so our function is going to be going up with a concave up. Okay, and so now what we're going to check is we're going to check to make sure our points are accurate based on the different slopes. So for example, at 0, we knew that the slope was -1, and so we've got about a -1 slope going there. And then we've also, we can tell per se at 2, we know at 1 and -1 at 0, so it's a max and min. At 2, we have a slope of about 3. So if you can check on there and see if about 2 we have a slope of 3.
That's around 3.
Around 3. You can just draw like a dotted line. Yeah. Okay. Just to make sure about right. And then at -2, we're going to have a slope of about 3 as well. Or 2.
So -2, or about 3.
And it's about 2 and -2. My bad for escalating it there.
It's all good.
Anyway, so now what we're going to do is, now that we have a rough graph, we're actually going to go back and look with the functions that we kind of had in mind when we did this. And so if you want to do that for f double prime of x, we had 2x kind of in mind when we formed the points. And so then for f prime of x, we had, x squared minus 1. And so then, off of this, we got our f of x would be, if you integrate it, x cubed over 3 minus x. And so now that we have a rough graph, we were just going to go through and check a couple of points on it. And so then we can tell the concavity does change for the critical point in the second derivative at x equals 0. And so I'm just going to write that there. And so we can go back to our original graph and we see that it shifts from concave down to concave up at about x equals 0. Then on f prime of x at x equals 1 and x equals -1, that's where we have our max and mins because the velocity is 0. And so we had that about right. And so then just to check where these values would be, we can plug in some values. So for example, at x equals 1 where we have our min, if we plug that in, we get 1/3 minus 1. And so this value right about here is going to be 1 negative 2/3. And so we got that about right just based on the slopes. And then -1, our max is going to be -1 comma 2/3. And so we can also see that's kind of taking shape. And then we can try to see about these values, say for example 3 up here. This is going to be 3, 6. And this is going to be -3, -6. And so this is just telling us that our slopes are accurate based on the velocity graph. So you got anything else you want to say?
Looks good. It goes from linear to quadratic to an x cubed function.
Mm-hmm. And so each time it increases by 1. And so I think that's it. Thanks, Trace.